Hello and welcome back to Mathletics with Sir Nawaz. So in today's video we are going to discuss the exercise 7b and it is about the volume and total surface area of a cone. So we know the shape of a cone, it contains two surfaces, one is the curved surface and other is the circular base. So volume of a cone equals 1/3 the base area multiplied to height, and we know the base is circular, so it will become 1 upon 3 multiplied to pi r square, and height is the vertical height h. So this is the formula for the volume of a cone. Then curved surface area of the cone equals pi r l, where we know l is the slant height and r is the radius. So the total surface area shall become the sum of two areas, the circular area and the curved area. So it will be pi r l plus pi r square. Now let us start exercise 7b from question number 1, and question number 1 have four parts. It states find volume of each of the following cone. In A part, as we see, we are given the radius which equals 6 centimeter and h vertical height equals 14 centimeter. So the volume, we know the formula for volume is 1 upon 3 multiplied to base area multiplied to height. So here the base area being a circle, it is pi times radius square and it is 6 multiplied to height, it is 14. So after we use calculator in order to figure out the value, it becomes 168 pi centimeter cube. So that is the volume in part A. Now in part B, as we can see, this one is the vertical height, h is equal to 5 centimeter, and we are given the base area which is 154 centimeter square. So we can apply the formula for volume directly. So volume shall become 1 upon 3 into base area is 154 multiplied to the height is 5. Once again, using a calculator, we can figure out the value of volume, and it becomes 256.67 centimeter cube again. So that was the B part. Now in C part, as we can see that this one is the diameter of cone. So if we are given the diameter equals 7 centimeter, definitely we need the radius of a cone, and we know radius is half the diameter. So it will become 3.5 centimeter, and we are also given the vertical height of the cone which is h. So the volume shall become 1 upon 3 into pi times radius is 3.5, so 3.5 square multiplied to height which is 14, and rest is again calculator's work. So it becomes 179.6 centimeter cube. So that is the volume in D part, C part. Now in D part, as we can see, we are given the vertical height, it is 28 millimeters, h is 28 millimeters, and the circumference of the base is given 132. Definitely in order to find the volume, we need its base area, not the circumference. So if we want to apply the formula 1 upon 3 pi r square h, we definitely need the radius, because circumference of the base is a circle, so circumference of a circle is 2 pi r. So 2 pi r equals 132, and because we need radius, so I will divide both sides with 2 pi, and we are left with r equals 132 divided by 2 pi, and it becomes 21 millimeters. So that is the value of radius, and now the volume shall become 1 upon 3 into pi into radius 21 millimeter square, and the height, we know height of the cone was 28 millimeters, and let us do the calculation using a calculator, and it becomes 941 millimeter cube. So that is the volume in part D. This was the question number 1. Now let's move to the question number 2. It states a cone has a base area of 20 meter square and a volume of 160 meter cube. Find the height of the cone. We know height of the cone is involved only in the volume formula, and we know volume is given 160 meter cube, and the formula for volume, we know it is 1 upon 3 into base area into height of the cone. And if it is 160, we are given the base area value, and I'm going to multiply 3 on both sides in order to get rid of 3 over here. Now it is left base area times height, and we know base area is 20, so it is 20 multiplied to h, which equals 16 times 3, which is 160 times 3, it is 480. And in order to find the value of h, we definitely need to divide both sides with 20, and after we cancel it out, it will become 24. So that is 24 meters. Height of the cone is 24 meters in second question. Now let's move to the question number 3. So in question number 3, it is given that the volume of a cone is 320 pi centimeter cube. Its base area is pi r square centimeter square, where r is a prime number. Suggest a value of r and find the corresponding value of height of the cone. So in this one, it is an open question as we see. So we have to suggest one value of r and then find the corresponding value of height. So as the volume is given, we will start with the volume. We know volume of a cone is 1 upon 3 times base area, and base area over here given is pi r square multiplied to height, and this equals 320 pi. Now as we are to find the value of height, so first we will make the subject h and then suppose some value of r. So first of all, I am multiplying 3 on both sides in order to get rid of 3 in the denominator. So it is pi r square h, which equals 320 times 3, it's 960 pi. Now let us divide both sides with pi r square, and here we are left with the h, and here pi is cancelled out, and 960 divided by r square is the value of h. Now we suppose some value of r, as it was given that suggest a value of r, and r is a prime number. So I will take any value of r, because prime numbers are 2, 3, 5, 7, 11, 13, and so on. So I can take any value of r from this one, but it will be better if we take any value of these three, 5, 7, and 11. So I'm going to start with the 7. If r is equal to 7, then h shall become 960 divided by 7 square, which will be 49. So after dividing it with the help of calculator, the value of h will become 19.6 centimeter. So that is the value of height if the value of radius is taken 7. And if we change the value of radius, if I take value of radius as 5, the height will be greater than this, and if I take the value of r11, the height will be smaller than this. So this was the question number 3. Now in question number 4, we can see a cone has a height of 14 centimeters. This is the vertical height of a cone, and a volume is 132 centimeter cube. Find radius of the circular base. So as we are to find the radius of the base, and we are given the volume of cone, it is 132 centimeter cube. So we know the formula for volume is 1 by 3 pi r square h, and if this equals 132. First I will like to multiply 3 on both sides and then replace the value of h over here. It will become pi times r is unknown and height is 14. So it will be 132 times 3, it will be 396, and let us divide both sides with 14 pi, so that pi and 14 on left hand side are cancelled out, and then we will find the value of r square with the help of a calculator. R square is 396 divided by 14 pi. So we will square root both sides and find the value of r with the help of a calculator. It becomes 3 centimeter. So that is the value of radius of the base. 3 centimeter is answer to the question number 4. Now moving to question number 5. It is stated find total surface area of the following cones, and as it is stated the total surface area, it is definitely total surface area equals pi rl, the curved surface area, plus pi r square, the area of circular base. So in A part, as we see, we are given the slant height over here, it is 7, we represent it with the L, and the radius of the base is given 4 centimeter, and these are the two things which we require in total surface area formula. For TSA, total surface area shall become pi times radius is 4, the slant height is 7, plus pi r square, it will become pi times 4 square. So after we simplify, it is 28 pi plus 16, so that becomes 44. That is the total surface area in A part. Now as we see in B part, we are given the diameter of the cone, and definitely we don't need the diameter of cone, we need its radius, and it will be half the diameter, 14 millimeters, and the slant height is definitely 30 millimeters. So we can directly apply the formula total surface area equals pi rl, here it becomes pi times 14 times 30, plus pi r square becomes pi times 14 square. So after we simplify, it will become 14 3s 42, so 420 pi plus 14 square is 196 pi. So adding the two, it will give us 616 pi in millimeter square. So that was the B part. Now in C part, as we see, the slant height is given 25 centimeter and the circumference of the base is given 132 centimeter, but we need definitely the radius of the cone. So first we will find the radius, because circumference is 2 pi r, and if it 2 pi r equals 132, the radius will be definitely dividing 2 pi on both sides, r equals 132 divided by 2 pi becomes 21 centimeters. So the total surface area shall become pi rl, pi times 21 times 25 plus pi r square, pi times 21 square. So here the total surface area for the D part shall become 21 times 25 is 525 pi plus 21 square is 441, so 441 pi, and when we add the two, the total surface area shall become 966 pi centimeter square. So this was the question number 5. Now let's move to the question number 6. Now in question number 6, it is stated that a cone has a circular base of radius 6 millimeters. Given that the curved surface area of the cone is 84 pi millimeter square, find its slant height. So as we are given the curved surface area, we know curved surface area is pi RL, and this equals 84 pi millimeter square. And we are given the radius R is equal to 6 millimeters, while we are to find the slant height of the cone. So as we can see, the radius is given. We can find the slant height very easily. It will become pi RL equals 84 pi. First, let us divide both sides with pi R, because we have to find the value of slant height. And here pi is cancelled out, and we will replace the value of R. So L becomes 84 divided by 6, and that shall become 14 millimeters. So 14 millimeter is the slant height of the cone. Now in question number 7, once again it is an open question. A cone has a total surface area of 1000 centimeter square. Find a possible slant height and radius of the circular base. Now we are to suggest one value of the two. We can either suggest the value of slant height, and otherwise we can suggest value of radius. So starting with the total surface area, we know the total surface area of a cone is pi RL plus pi R square, and this equals 1000 centimeter square. So we can suppose any of the two values. I am going to start with the value of R. Suppose that R is equal to 10 centimeters, and after we replace this value, it shall become pi times 10 times slant height plus pi times 10 square. It equals 1000. So this one becomes 10 pi L plus 100 pi equals 1000. So let us subtract 100 pi on both sides in order to cancel out the 100 pi on left hand side. So we are left with 10 pi L equals 1000 minus 100 pi, and then we will divide both sides with 10 pi, because we need the value of slant height L, and rest is the calculator's work. So just plug in the values in the calculator and it will give us the value of slant height. So it becomes 21.8 centimeters. So that is the value of slant height if the value of radius is R centimeter. So if we change the value of radius, it will definitely change the value of slant height as well. But slant height must be greater than the radius, because slant height is the greatest value of the three values of the cone. From the radius and height, slant height is the greatest. Now in question number 8, it states an open cone has a slant height of 5 meters. We are given L is equal to 5 meters, and a curved surface area of 251 meters square. Find the radius of the circular base. So first of all, we are given the curved surface area. It is pi RL, which equals 251 meter square. We are given the slant height. It is 5 meter, and we are to find the radius, and that is again very easy. So pi times radius times slant height is 5. If it equals 251, so 5 pi R equals 251. Let us divide 5 pi on both sides. 5 pi is cancelled out, and 251 divided by 5 pi equals 15.98 meters, or we can also round it off to the nearest whole number, and that shall become 16 meters. So that is the value of R in case of question number 8. Now let us move to the question number 9. Now in question number 9, it states find the order of rotational symmetry of the following cone. And we know the order of rotational symmetry, it depends on the base of the cone. And as we are dealing with the circular bases, so the order of rotational symmetry of a circle is infinite. Order of rotational symmetry of circle is infinite, because we know the all sides of the circle, or we can say the radius of the circle, is equal. Like if it is the center of the circle, then the distance of the center from all sides from the circumference is all the same. So the order of rotational symmetry of the circle is infinite, and that is the order of rotational symmetry of the cone. Order of rotational symmetry of cone equals infinite. So that was the question number 9. Now in question number 10, we see it states for a right circular cone, state the number of planes of symmetry, the number of axes of rotational symmetry. Again, the number of planes of symmetry, that also depends on the base. And as it is a circular based cone, the number of planes of symmetry is also infinite, because the number of planes of symmetry Why is it infinite? Because the number of lines of symmetry through its base is infinite. As we see, the base is a circular base, so the number of lines of symmetry through the circle is infinite, and that is the number of planes of symmetry for a right circular cone. And the number of axes of rotation symmetry, and there is only one axis of rotation symmetry, which is passing through the apex and the center of the base here. This is the only only axis of rotational symmetry. For the second, there is only one axis of rotational symmetry. So this was the question number 10. Let's move to the question number 11 now. It is stated that a conical funnel of diameter 23.2 centimeter. We are given the diameter of the funnel 23.2 centimeters and a depth of 42 centimeter. Contains water filled to the brim. The water is poured into a cylindrical tin of diameter 16.2 centimeter. If the tin must contain all the water, find its least possible height, giving your answer correct to the nearest integer. So we are given a conical funnel with the diameter 23.2 centimeters. So I'm going to draw it over here. Suppose that this is a conical funnel, and it contains the water to the brim. Its diameter, as mentioned, is 23.2 centimeters, and its depth is mentioned as 42 centimeters. So that is the uh, conical funnel, and it stated that the water is poured into the cylindrical tin. This conical funnel contain water, it is filled with the water, and this water is poured into a conical funnel whose diameter is a little less than the diameter of the funnel. So suppose that this one is the cylindrical tin in which the water is poured down, and we are given the diameter of its base. The diameter of its base is 16.2 centimeters. So first of, and we have to find the height of this cylindrical tin. I am representing height with the h. Now as we are given the two radii, this one is the diameter. Okay, so the radius of the funnel will be half of that. I'm representing it with the capital R because this is the greater one. The other radius will be the smaller one. So it is 11.6 centimeter. That is the radius of the conical funnel, and the radius of, because we know this is the diameter of this cylindrical tin, so its radius will be half of this, it will be 8.1 centimeters. And we have to find the value of height. It stated that the tin must contain all the water, so the volume of water, the volume of conical funnel must equal the volume of cylindrical tin. The volume of funnel, that's how it will contain all the water from the funnel. The volume of funnel shall equal the volume of cylinder, and we know funnel is a cone while it is a cylinder, and the formula for volume of a cone is 1 by 3 pi r square h, and the value of radius of the cone was 11.6. So 11.6 square times the height, which was 42, and this shall equal the volume of cylinder. We know the formula for volume of cylinder is pi r square h, and the radius for the cylinder is 8.1 square, and height is unknown. Now we start simplifying it. First of all, let us multiply 3 on both sides, so that this denominator 3 is cancelled out. Pi can also be cancelled out on both sides, so we are left with 8.1 square multiplied to 3 multiplied to h, which equals 11.6 square multiplied to 42. Now in order to find the value of h, let me divide 8.1 square multiplied to 3 on both sides, and the rest will be done using a calculator. So let us find the value of height using calculator, and it becomes 28.7 centimeters. So that is the height of the cylinder as it stated, giving your answer correct to the nearest integer, and if we round off it to the nearest integer, the height shall become 29 centimeters. So 29 centimeter must be the height of the cylindrical tin in order to contain all water from the conical funnel. So this was the question number 11. Let's move to the question number 12 now. So in question number 12, a conical block of silver has a height of 16 centimeter. We know h equals 16 centimeter and a base radius of 12 centimeter. So r equals 12 centimeter for the conical block of silver. The silver is melted to form coins 1 upon 6 centimeter thick and 1.5 centimeter in diameter find the number of coins that can be made. So first of all, the number of coins that can be made will be the total volume of silver divided by the volume of one coin, divided by volume of one coin. So first of all, we find the total volume of silver. As we see, it is a conical block of silver, and the volume of silver will equal the volume of cone 1 upon 3 pi r square h, where the radius of the cone is given 12 centimeter and the height is 12 square into height is 16. So that will give us the volume of silver. And it equals 768 pi centimeter cube. So that is the total volume of silver we have, and we are reshaping this conical block into the coins, and we know the coins are cylindrical, so definitely we need the volume of one coin. So volume of one coin will be pi r square h, where r is the radius of the coin and h is the thickness of the coin. We know h is given 1 upon 6 centimeter, that is the thickness of the coin, while we are given the diameter of the cone, which is 1.5 centimeter. It is 1.5 centimeter, or we can also write it 3 upon 2 centimeter, but we need the radius, and that will be definitely half of 1.5, 0.75 centimeter, or we can write it as 3 upon 4 centimeter as well. So now replace the values over here. Pi times 3 upon 4 square, and height is 1 upon 6, which is the thickness of the coin. And now we find value with the help of calculator. That will be the volume of one coin, and it is 3 upon 32 pi in centimeter cube. Now as we need the number of coins, and we know number of coins is total volume of silver divided by volume of one coin. Number of coins equals total volume of silver divided by the volume of one silver coin, and that shall become 768 pi divided by the volume of one coin was 3 pi divided by 32. So after we divide it with the help of a calculator, and the number of coins shall become 8192. So that is the number of coins that can be made with the given conical block of silver. Now in question number 13, as we see, we are given an open cone as a circular base of radius 10 centimeter. It is an open cone, so there is no base of this cone, and a slant height of 20 centimeter. Draw the net of the cone and label its dimensions. Now first of all, when we say draw the net of the cone, when we open a cone, it actually becomes a sector of the circle. So let's suppose that I have this cone over here, like its dimensions are, the slant height is 20 centimeter, this one is 20 centimeter, and the radius over here, it is given as 10 centimeter. And when I open this cone, when I draw its net, it will become a sector, and we know there are two things in a circle. One is the radius of that sector, and other is the angle at the center of sector. Now when we are opening this cone into a sector, the radius of cone basically becomes the slant height of the cone basically becomes the radius of the sector. So radius is 20 centimeter. Now we need the angle at the center of the circle. In order to find the angle at the center, we will use the total surface area, because when we open an open cone into a sector, the total surface area will remain the same, and curved surface area, we know it is pi RL. So it becomes pi times radius of cone was 10 and the slant height was 20. So it becomes 200 pi. So 200 pi is the curved area of the cone, and now it equals the area of sector, and we know area of sector is angle at the center. If I call it is theta, suppose, so it will be theta divided by 360 multiplied to pi times radius square. Now radius of the sector over here is 20, so it will become 20 square. Now we need to solve this equation in order to find the value of the angle theta. First of all, I'm going to cancel pi on both sides. Now we move 360 to the right hand side, so it will become 200 times 360 equals theta multiplied to 20 square is definitely 400. So I'm dividing 400 on both sides. So it will be theta equals 180 degree. So if this angle is 180 degree, it will actually become a semicircle. It is a semicircle with the radius of 20 centimeters. So these are the two things we need to mention in the net of this cone. So this was the question number 13. Now in question number 14, if we see, it say the semicircle shown is folded to form a right circular cone. We know whenever we fold any sector or a semicircle, it converts into an open cone, so that arc PQ becomes the circumference of the base. We can see that this PQ arc is a semicircular arc, and it converts into the circumference of the base of that cone. Given that the diameter of semicircle PQ is 10 centimeter, find the diameter of the base of cone and curved surface area of the cone. Now we are given the diameter of this semicircle, so its radius will be definitely 5 centimeter, because whenever we fold a sector, it converts into a cone, and the radius of that sector equals the slant height of the cone. Let's suppose that this was the semicircle over here, and when its radius is 5 centimeter. When I fold this, it converts into a cone, so the slant height of cone will equal the radius of the circle. So the slant height L equals 5 centimeter. Now and it was given that PQ becomes the circumference of the circle, and PQ is a semicircular arc. We know the circumference of circle is 2 pi r, but the semicircle, it will be divided by 2, so it shall become, r was 5, so I can say that PQ arc is 5 pi, and as we know that this 5 pi equals the circumference of the base. If I say that the radius of this cone, suppose that it is capital R, so it will be 2 pi capital R equals 5 pi, and after we divide 2 pi on both sides, it will be 5 by 2 centimeter or 2.5 centimeter, but that is the radius of this cone, the base of the cone. we need its diameter, and definitely that will be the double. So diameter is definitely 5 centimeter. The diameter of the cone is 5 centimeter. Now we need the curved surface area of the cone, and we know the curved surface area of cone equals pi r l. Curved surface area equals pi r l, and the radius of the cone is 2.5, remember. So 2.5 times slant height is 5. So it will become 12.5 pi centimeter square. So that is the curved surface area of the cone. This was the question number 14, remember. Whenever we fold a sector or a semicircle, it will convert into a cone. So now move to the question number 15. Now in question number 15, a cone has a circular base of radius 5 centimeter and a height of 12 centimeter. Find the curved surface area of the cone. We know the curved surface area of cone equals pi r l. Curved surface area equals pi times radius times slant height. But here we have the radius and the vertical height of the cone. So in case of a cone where we are given the radius and the vertical height, we use Pythagorean theorem to figure out the value of slant height. As we know, this side over here, this is the vertical height and this one is the radius, and these are perpendicular. Radius is 5, vertical height is 12, and we use Pythagorean theorem in order to find the slant height L. So it will become L square, which is the hypotenuse, equals 12 square plus 5 square. So in order to find the value of slant height, we will square root both sides, and this shall be square root of 169, and this is 13. So slant height is 13 centimeter. Now replace the value over here in the formula. So the curved surface area becomes pi times radius was 5 times slant height is 13. So it becomes 65 pi centimeter square. So this was the question number 15. Now in question number 16, as we see, we are given a cone has a circular base of radius 8 centimeter and a slant height of 20 centimeter. Find the volume of the cone. We know volume of a cone equals 1 upon 3 pi r square h. Here we have radius is equal to 8 centimeter, but we are given the slant height L 20 centimeter and not given the vertical height. So once again we will use Pythagorean theorem in order to find the value of vertical height. We remember that if this is the radius and this is the vertical height over here, then here is the slant height and they form a right triangle. This one is radius 8, vertical height h is unknown, and the slant height L is given 20. So again apply the Pythagorean identity and it will become like h square plus 8 square equals 20 square. So h square shall equal 20 square minus 8 square, and then square root both sides in order to find the value of h. So it becomes 18.33 centimeters. So that is the value of vertical height h, and now we replace it in the formula for the volume. So volume will equal 1 upon 3 pi times radius 8 squared times height 18.33. So again we use calculator to figure out the actual value of the exact value of the volume. It is 1228 centimeter cube. So that is the volume of the given cone in question number 16. Now in question number 17, as we see, it is given that a circular cone has a height of 17 millimeters and a slant height of 21 millimeters. Find the volume and total surface area of the cone. Again, we are given vertical height and slant height. But in order to find the volume, we need radius and vertical height. So we will again find radius with the help of the Pythagorean theorem. Remember that if this one is the radius, then vertical height h is over here, they are perpendicular, and slant height is the hypotenuse of this triangle. This is slant height L, this is the vertical height h. H is given 17 and slant height is given 21. So we will apply Pythagorean theorem, and that becomes r square plus 17 square equals 21 square. And r square shall become 21 square minus 17 square, and then we take root using a calculator. So r becomes 12.33 millimeters. So that is the value of radius. So the volume shall become 1 upon 3 pi r square h, 1 upon 3 pi times radius 12.33 square, the vertical height 17, so it becomes 2706 millimeter cube. So that is the volume, and then it was the total surface area of the cone. We know total surface area of the cone equals pi r square plus pi r l. Total surface area so it becomes pi times 12.33 square plus pi times 12.33 into the slant height, which was 21, and again we use calculator in order to figure out the exact value of the total surface area. 1291 millimeter square. So that is the value of total surface area of the cone, and here was the volume of this cone. So this was the question number 17 of this exercise, and I hope that these questions are enough to practice the volume, surface area and symmetry of cones. So in next video we will start the next exercise, which is about the volume, surface area and symmetry of sphere.